So on behalf of the Florida Concrete and Products Association, I'd like to thank you for joining us today with the presentation about Portland limestone cement. As I said earlier, feel free to type any questions you have in the chat function, and we'll have a Q&A at the end of this presentation. So let's go ahead and get started. This presentation has been adapted from the Portland Cement Associations. The PCA is the National Trade Association for Cement Manufacturers in the United States and represents the vast majority of manufacturers in the US. For those not familiar with cement as a product, it is the powder that is the primary binder in concrete that makes it get hard. Concrete is the finished product that we see, such as a foundation, a road, a sidewalk, etc. This presentation will be conducted in accordance with FCNPA's antitrust policy. Thus, as stated here, there will be no discussions regarding pricing, terms, costs, plans, bidding, customers, etc. If you have any questions or concerns, please let us know. This presentation is brought to you by the Florida Concrete and Products Association and Florida Cement Manufacturers, Argos, Ash Grove, Cemex, and Titan. Your presenters today are myself, Justin Fleming from Ash Grove, and Byron Velasquez from Argos. We are both members of the PCA and FCPA and have cement plants here in Florida and other parts of the United States. So these are the topics we're going to cover today. This is a product that can be used anywhere where type 1 or type 1-2 Portland cement, namely 1-2 here in Florida, is produced, and it is produced here in Florida by all of the cement manufacturers. This is a non-proprietary informational presentation to prepare you for the future, as this product will eventually replace type 1 and type 1-2 Portland cement in bulk and packaged form. So a PLC, or a Portland limestone cement, is a blended cement with limestone as the non-Portland component. This cement is common in Europe and countries around the world. Here in the US, PLCs are a cement type containing anywhere from 5% to 15% limestone by volume. This product provides a means of implementing a proven technology to obtain desired performance and an option to improve the sustainability of cement and concrete. So you might hear these products called different things by different groups. Type 1L is the product produced here in Florida, and these designations are in the standards ASTM C595 and AASHTO M240. So for example, the percentage of limestone is given in parentheses. The nomenclature provides this complete transparency for producers and users. In this example, type 1L10 designates a type 1L cement with 10% limestone addition. So what is PLC, or Portland limestone cement? As I mentioned earlier, Portland limestone cements vary a little bit from ordinary Portland cements. So a traditional or ordinary Portland cement contains up to 5% limestone, whereas Portland limestone cements are made by intergrinding that same clinker, but now we're adding up to 15% limestone. Portland limestone cement is also a finer ground product than traditional Portland cement, and that's how we get equivalent performance, which Byron will talk about a little later. Also, it offers a reduced environmental impact. So since the 1970s, improvements to US cement manufacturing have resulted in more than a 40% decrease in production energy. CO2 released from the cement manufacturing process has two main components. One of that is combustion and grinding, which is where natural gas and coal is used to heat a kiln to 2,700 degrees Fahrenheit, and electrical power is then used to turn a finish mill, which grinds that clinker into powder. This heat is used for the second component, calcining, which is breaking the chemical bonds of limestone, which is calcium carbonate, into lime, calcium oxide, and calcium dioxide. So roughly 60% is just that breaking that chemical bond, where the other 40% is actually using the fossil fuels and electricity. So this limestone is a key ingredient in cement manufacturing, and PLC represents an opportunity to further decrease the carbon footprint and greenhouse gases of cement. So as you can see here, our biggest opportunity for reducing CO2 is basically manufacturing a product that uses less CO2. So with Portland limestone cement, CO2 emissions are about 10% lower versus ordinary Portland cements from the manufacturing process. This allows manufacturers of PLCs to cut CO2 emissions by about 10%. So why is this important? Well, PCA member companies are committed to achieving carbon neutrality across the entire value chain by 2050. The PCA roadmap involves the entire value chain starting at the cement plant and extending through the entire life cycle of the built environment to incorporate the circular economy. Both an executive summary and the full report are available on PCA's website at cement.org. And several cement plants across the US have already committed to only producing PLCs at their plants in lieu of ordinary Portland cement. Does your organization, stakeholders, or clients have a sustainability initiative? If so, using PLC can help. So the Global Cement and Concrete Association, or GCCA, is also committed to carbon neutrality. And the GCCA 2050 Cement and Concrete Industry Roadmap for Net Zero Concrete is the collective commitment of the world's leading cement and concrete companies to fully contribute to building the sustainable world of tomorrow. This roadmap sets out a net zero pathway to help limit global warming to 1.5 degrees Celsius or about 2.7 degrees Fahrenheit. The sector is committed to producing net zero concrete by 2050 and is committed to acting now. This full report is available on GCCA's website at gccassociation.org. So this is a busy slide, but the materials to the upper right have a higher embodied energy and CO2. Notice that concrete and cement are toward the lower left when compared to a wider range of other materials. Cement and concrete have relatively low embodied energy and CO2 content on a mass basis, even when compared to wood and other materials. More concrete is used annually than any other man-made material by a factor of about 10. Concrete is the most consumed material on Earth, second only to water. Thus, it is important to look for improvements in concrete sustainability. Something like 50% of all man-made materials are concrete by mass, and therefore account for 5 to 7% of the world's CO2 production. And that's really important. The corollary of this is that anything we replace with concrete will likely drive up overall emissions and energy usage, even if we had the volume of materials to replace that with something different, which we don't. So what are some of the PLC benefits in a ready-mix situation? Well, you're going to see equivalent strengths to traditional Portland cement. You're going to get improved finishing and pumpability of the concrete, and it's going to contribute to the environmental footprint of the structures as a green building solution. When it comes to the benefits in blocks and pavers, You're going to get equivalent strengths again compared to traditional or ordinary Portland cement type 1-2. You're going to get reduced efflorescence in concrete block and pavers. And again, you're going to contribute to that overall environmental green footprint of the structures and provide a green building solution. So I'm going to turn it over to Byron now, and he's going to pick up and tell you even more about type 1L cement.
Thank you, Justin, and thank you everybody for being here today to talk about this subject, which is very important for our industry. This will allow us to reduce our carbon emissions and reach the goals that the GCCA and even governmental entities they have. But overall, it will help us reduce the carbon footprint in all of the construction. So let's continue with the concrete once again. Yes, it is indeed, it is used all over the place and it is widely used. Actually, why exactly? Because it's economic, it's plentiful, it's popular, right? I mean, you can do whatever you want with concrete. And in fact, builders know it, the engineers know it, the architects know it, and we use quite a bit at a rate of 15 billion tons a year. That's quite a bit. So like Justin was saying, I mean, the concrete has one of the lowest embodied carbon of all building material. The problem is the volume, right? We use so much that it creates a CO2 issue, and then we'll see why. So why are we going to use PLC? I mean, what's the benefit? In fact, you know, it's an option to implement a proven technology. Why? Because it has a very good track record throughout the world in all kinds of climates, in the harsh Canadian winters, in marine exposures, and all over all other applications. So in fact, I mean, we use this product like it's new. It's really not new. I mean, it's been around the world for over 60 years, right? But this PLC will give us the desired performance, and it will improve the sustainability of concrete and construction in general. It's all about sustainability in this moment, and performance and porosity, and I will explain later why. But you can achieve beautiful projects using sustainable products, and a sustainable product is the PLC, right? Even large companies like the Amazons of the world, the Microsofts of the world, the Facebook, well, now Meta platforms, that's how they call themselves, Salesforce, they have committed a carbon reduction in by 2030, 2040, and so on and so on. So not only did they apply it on the supply chain and their products, but also in the construction of their warehouses and buildings. So like Justin said, concrete has a very low or relatively low carbon emission per unit, but because we use so much of it, I mean, that's where we have to modify something, right? And by using PLC, which is an engineered system that provides an equivalent cement, then we can achieve sustainable objectives that are very, very interesting. So OPC versus PLC, what is it exactly? I mean, it's an engineered increased limestone for equivalent performance. And when I say this, I mean, some people may say, well, it's just adding limestone to the system. Well, it's really not. It's optimizing the chemistry, and there's a lot of engineering behind the production of PLCs. The PLCs can provide us some significant potential greenhouse gases reduction, you know, at the rate of 10 to 12% if they are used properly. And you can even achieve greater reduction in the carbon dioxide by using SCMs, right? When I say SCM, is supplementary cementitious material like slag, fly ash, metakaolin, pretty soon calcined clays, ground glass also that is becoming a little bit more popular. It still has a lot of work to be done, but that's a very good product as well. So let's focus on where is the CO2 coming from, like Justin said, absolutely from the calcination, from the combustion and all that. And I want you to focus on this diagram right here, right? So it shows that the chemical composition of limestone, calcium carbonate, when it breaks down, when it's heated, breaks down, it produces lime and carbon dioxide, and this is where we want to reduce this emission, because it's not only carbon dioxide, also it's NOx and some other products that are not, or emissions that are not very good for the environment. But we want to reduce the carbon emissions in this case, right? There was a study by California Department of Transportation recently, and these are the main conclusions. I'm not going to go through all the study, but what they've seen is that the PLC and the OPC plus limestone systems, right? They took OPCs and they added limestone, and they were found to have a greater degree of clinker reaction, right? You know, in the testing that we've done and that I've seen in the past is pretty much equal, but you know, it all depends on the degree of the reactivity of the clinker and the grinding as well. So in their conclusions, they've seen an increase of clinker reaction, which is very good also. The system also had similar or improved ASR. That's very important. When I say ASR, is alkali silica reaction, and this is very important if you're doing doing business or if you're doing an FAA project, right? They're all over into the alkali silica reaction, right? And this is due because of the alkali loading in the system is reduced, right? There's less clinker in the PLCs. It also, on the shrinkage side, it was pretty much similar. The flexural strength was average. It was pretty much the same, but they concluded in the past in the fact that that overall everything is pretty equal, and we can get a reduction of GHGs by in the rate of 10 to 12%. Which is very interesting. So let's look at the acceptance of PLCs in the United States and the DOT approvals, right? So this was the map in April 2020, right? You see a lot of yellows on the West Coast and on the Northeast. That was just a little bit over a year ago. This is what we had. This is what we have right now as of October 2021. You see the difference right here. All the yellows are starting to disappear. The Northeast, I don't know what's going on with them, but a lot of promotion, a lot of you know, training needs to be done with those DOTs in order for them to accept the PLCs. But overall, there's a wide acceptance of PLCs in the Department of Transportations. The other thing I want to mention is the AIA, but I'll mention that later on. The AIA, the FAA also approve the PLCs in their projects. So there's you know, I'll talk a little bit about the process of the acceptance of PLCs within the Florida Department of Transportation. It's not just that you provide the information to the FDOT and they will approve it for you to use in one of the projects. Well, there's a battery of testing that needs to be done for them to approve the PLC, and I believe all the cement manufacturers in the state of Florida are now FDOT approved, and that you can look at it on their website, on the FDOT website. You'll see all the manufacturers that are approved and what type of cement as well. So as far as the cement companies, they have to provide an extensive battery of testing. As far as the chemistry of the cement, the physical aspect, also all the testing has to be provided, the heat of hydration as well, but also concrete testing has to be done, and this is by a third party, right? You can do all the testing that you want internally, but you have to provide testing performed by a third party of their choice that has to be approved, right? So the surface resistivity at 28 days, the compressive strength, of course, and the 3.3 and 4 are the durability, the chloride diffusion testing, and the sulfate resistant testing, also the C1012. That has to be performed, and the results have to be provided to the FDOT with successful testing in order for the PLCs to be approved in any FDOT project, right? Once that is done, then the FDOT issues a material bulletin where it will say that that they are allowing a substitution of type 1.2 by the type 1L, right? So there is a battery. There's a lot of testing that has to be done in order for the FDOT to approve the PLCs in their projects, meaning that all of the test results have to be successfully achieved before anything can happen, right? Other approvals are the AIA, the ACI 318 incorporates the Portland limestone cement in their specification and in their codes. The IBC as well references the ACI 318. Like I mentioned earlier, the Federal Aviation Administration references PLCs in the spec P501, and also the U.S. Army Corps of Engineers also approves the PLCs. In this moment, I believe it's on a project basis, but overall, the PLC is approved. Just a quick reminder, I mean, with the ASTM C150, the ASTM C150 that all the engineers know and the architects, the specifiers, they always use ASTM C150 in the specs. Well, this specification allows a maximum of 5% limestone already in the cement, right? But it's cousin, the ASTM C595, and this is where we have to tell the specifiers to include the ASTM C595 in the project specs in order to use the Portland limestone cement, right? The type 1L. This, like Justin said, the Portland limestone cement allows a ground limestone from 5 to 15% by mass. So how does limestone work exactly? Okay, so bear with me on this diagram. So on the x-axis, you'll see the amount of limestone in percentage that is added to the system, ground limestone. On the y-axis, it would be the porosity, okay? And the red dots are the strength. So if we start at 0 right here, we start adding a ground limestone to the system, right? The OPC, we start adding limestone. Up to 2-3%, you can see that the compressive strength increases, the porosity decreases, which is very good, right? But what we're looking for is an equivalent product, That's how much limestone can we add to the system in order for it to be equal to OPC. So as the limestone keeps increasing, then of course, you know, the compressive strength decreases, but it is still higher than the OPC, all the way up to 15%. That's how the researchers throughout the world, and for many years they determined that 15% was the right percentage, a maximum percentage of limestone addition. How does limestone work? So we're counting on particle packing, like Justin said. The clinker and the limestone are underground. The clinker is a tougher material, a harder material. The limestone is softer, so we will have a lot of fine particles. Those fine particles will find their way between the cement particles, and they will fill the voids to have a denser matrix, right? And that's what we call the particle packing, right? So you'll have that. Also, because the particles are closer by, then there's nucleation and there's a denser matrix here as well. As far as chemical reaction, I mean, the limestone is innocuous, so there's not a huge amount of chemical reaction when you add PLCs. As far as the performance of fresh and hardened concrete, those fine particles will heavily influence the fresh and hardened concrete properties, like the workability, the strength development, the compressive strength, the shrinkage, and durability. So we count on those fine particles, right, to help us reach the equivalency to OPC. So as far as properties, then the workability is pretty much the same. The bleeding in your concrete should decrease, and that is because of the higher surface area. Like I said, there's more fine particles that will find the voids where the water wants to percolate or wants to go up to the surface, and those fine particles will reduce the bleeding. The set times are pretty much equals, and the heat of hydration slightly increases depending on the reactivity of the clinker. As far as the hardened concrete properties, then what we've seen, at least here in Florida, is that it's pretty much the same. Some people have seen an increase, slight increase in strength at 1 day, at 28 days, and pretty much equal in 90 days, right? Again, the mechanical properties, tensile strength, flexural strength, modulus of elasticity, the shrinkage are pretty much equal, right? And that's exactly what we want. That's what we're looking for. So there's two professors in Canada, Michael Thomas from the University of New Brunswick, and Dr. Doug Hooton from University of Toronto, who have done some extensive research and testing on PLCs, right, with or without SCMs. So in Canada, PLCs are widely used, a lot more than here in the US. So their testing concluded that they've seen a similar performance as far as strength without SCMs, and with SCMs, like I said, they've seen kind of an increased strength, early strength here. They say 12%, but that it all depends on the reactivity of the clinker, right? In our case, we have seen pretty much equal performance, right? At later days, 28 and 56 days, looking at an important test, which is the RCPT, the permeability test, the C1202, then you're looking at equivalent performance here, whether you're using a water cement ratio of 40 or 0.45, with or without slag. And of course, I mean, the addition of SCMs will improve the performance of your PLCs. So what's up with the interaction with SCMs, right? There's some synergetic interactions that have been reported between the PLCs and the slag, and that is due to some chemistry that is developed between the limestones and the slag. You'll have greater strengths over time, and that is true for OPC regardless, right? I mean, the later ages with of a concrete with slag will be drastically improved over time, and it's the same thing with PLCs. Actually, it may increase the later strengths, improve durability because there's less voids in the matrix, in the concrete matrix, so there's less porosity, right? There's less porosity, there's less intrusion of sulfates and chlorides in the system, meaning that you'll have a better system, and obviously, and that's by optimizing your mix design and with the water cement ratio as well. Fly ash, they produce pozzolanic reactions, and that's very beneficial. It creates a better concrete when you have PLCs as well. So a few takeaways. Reduction of porosity in PLC system occurs due to the stabilization of some chemical reactions, like I said. The calcium carboaluminate work well, and that's in the reaction with the slag and the limestone, that those synergies work very well. Overall, of course, the PLCs are improved with SCMs. Like I said, aluminas react very well with limestone. That's where the chemistry happens. It lowers the porosity, right? So using SCMs in your mix design is beneficial when using PLCs. So in summary, PLCs and SCMs will allow you to reduce the carbon dioxide emissions, right? By reducing the amount of cement, by reducing the amount of clinker in the system. And this objective is done, will give you a 10 to 12% reduction of carbon dioxide, which, you know, doesn't seem like a lot, but because there's so much concrete produced around the world, that it can be significant. It can be very, very interesting. And actually, again, I mean, by using the SCMs, you can perform even better. So PLCs is an engineered product, right, with improved performance. The cement manufacturers need additional grinding time in order to produce this PLC, and there needs to be an optimization of the chemistry. Otherwise, it will not perform as determined. So the ASTM C595, please do not forget that, because there's already commercially available solutions through the specifications. So anytime you're dealing with a specifier, do not hesitate to mention ASTM C595. And in this case, I mean, there's a lot of information online. There's a lot of testing results, even the PCA, the GCCA, greenercement.com, that people can read about it. A quick summary. So it's all about sustainability and porosity, right? Like I said, I mean, the less permeable your concrete matrix is, by using PLCs and using SCMs, you can achieve not only a better performance with concrete, but also we can achieve sustainability by reducing the greenhouse gases with the cement in the cement manufacturing. So this little diagram here shows you reduce the clinker, you reduce with the PLCs, you reduce the cement content by using SCMs. It will give you a life cycle performance and achieving the sustainability that we are looking for. All right, let's take a look at some projects now. And this is a project that was done near Tallahassee. The contractor used PLCs in a bridge deck. It was successfully done. This one, another bridge deck that was done near Tallahassee, successfully done as well. Here's another one. It seems like there's a lot of in the Tallahassee area, but all these you can research on them and go to the FDOT website on the internet, and you'll be able to find and study a little bit more of that. So in terms of condominium structures, then here the PLC was used in 8,000 and 10,000 PSI elements, and the PT slabs, this was a straight type 1L mix. 8,000 PSI was reached, and also 10,000 PSI with a mix of slag and type 1L. So these are very successful projects that were done. This one is in Tampa, near West Shore, I believe. The Bayway Bridge, another important project. There's two of them, and this used quite a bit of slag in it. The FDOT, who is the client, decided to go with a 70% slag mix. Okay, and for multiple reasons, for the heat of hydration and for durability as well. So the Portland limestone cement was used in this important bridge as well. The St. Pete Pier is worldwide renowned. The Portland limestone cement was used in the mixes as well, with slag at a rate of 50%. I think the bid from the architects or the design came from around the world, and ASD Architects was chosen for this project. The Daytona Convention Center also used a Portland limestone cement. There was quite a bit of concrete that was used in this very successful project as well. So I think Justin, I'll give it up to you. Thank you very much. If you have any questions, just let us know. I'll switch it to Justin.
Thank you, Byron. All great information. And I think it's also worthy to note, we mentioned all the different standards and codes that PLCs are accepted in. In these projects and other around the state of Florida too, it's worthy to note that both the Florida Building Code and the Florida Residential Code also accept the use of PLCs through their adoptance of ASTM C595 for blended cements. So as Byron mentioned, it's used in a variety of projects. The Daytona Convention Center here, 27 stories tall, 31 stories tall, almost 80,000 cubic yards of concrete. It's also used in a variety of projects. We talked about bridge decks before. Here's the Gateway Expressway over in Clearwater. Cast in place project, bridge deck, elevated, all of the above. It's also used on commercial projects. So this cabin at April Farms is a tilt wall project that was 15,000 yards, use type 1L PLC. The School Triple T in Hillsborough County, again, another tilt wall project, 13,000 yards of concrete made with type 1L PLC. Some additional information that may be valuable to you is some of these reports that PCA has put out. This technology has been common in Europe for several decades, and there's a lot of technical literature available on a wide range of topics related to the use of limestone in cement. And these two recent reports are available for free. The links will be included with the email that's sent out after this, or you don't get them or you need them, just feel free to reach out. They're also available on PCA's website, cement.org. And PLC also has its own dedicated website that PCA has created called greenercement.com. And it's a great resource that also has a ton of information and resources and research. I highly recommend the videos on this website because they're very easy to digest and they convey all of the information in a easy to understand and entertaining format. So with that, I would like to conclude our presentation. Looks like we got done a little early, so we would be happy to answer any questions that you may have, or if you think of one while you're listening to some of these, feel free to type it in the chat box and Carl will relay that to us.
One question came up about a recording for the webinar. The Florida Concrete and Products Association's YouTube channel will have recordings on it of any of the webinars that we do. But everybody that's registered for this webinar will get a recording emailed to them as well. There's a few other questions that have come in. And first question is, are there any noted issues with consistent air content?
Not that I'm aware of. Byron, do you have any additional information on that?
No, not at all. We haven't seen that. You know, normally the LOIs in the ash, in the fly ash may kill the air, or but as far as the PLC itself, no, we haven't seen that. What we've seen though is an increase in water demand, very lightly, but that's what some people have said. Some other ones have switched to type 1L without any issues at all. So to come back to your question, I haven't seen any air issues at all.
Okay. Next question is, what are your thoughts about concrete producers using ground limestone separately to optimize performance and costs?
I would say as long as they can get the results they need in their overall mix designs, to feel free. Byron, you have any thoughts or comments on that?
Yeah, no, I mean, researchers have shown that you can use PLC in all kind of application, all kind of mix design, whether it's grout, whether it's concrete, as long as you optimize your mixes, right? That's the main part. You have to do some testing prior. That's what we recommend. Regardless, just please do some testing, making sure that the PLCs are what you're looking for in your mix designs. It doesn't have to be extensive testing, but you need to do it. But no, overall, I mean, the durability is there, the strength is there. There shouldn't be any problems with any application.
Next question, in the past, FAA hasn't allowed 595 cements. Has the FAA accepted the use of IL cement?
Byron, I'll punt to you on that one, but I believe so, from what you said earlier, correct?
Yes, indeed. If you look at specification P501, you'll be able to find the Portland limestone cement there. Yeah, it's important to mention that it's type 1L. That's how the PCA likes to, despite the fact that we say IL or that we write IL, is the cement type 1L. But no, I mean, like the AIA, the FAA does allow the use of Portland limestone cement in their projects by looking at specification P501. It was probably not there before, but it's been updated. And actually, the U.S. Army Corps of Engineers also allow the PLC in their projects.
Do you know if the imported cements are coming in with 10 to 15% limestone, or do you have an idea?
It's going to vary by manufacturer, but what I've seen are their type 1-2 Portland cements, so they're up to 5%. I have not seen any 1L or PLC cements imported into the state of Florida yet. Byron,
Yeah.
any addition?
Yeah, just I haven't seen any, but regardless of that, if a PLC is to be used in an FDOT or FAA project, they need to be certified by those entities. If they're not, then they cannot use it, right? That's why I mentioned about the FDOT website to go and see which cements are approved to be used on their projects. But as far as imports, I haven't seen any.
Do you know if there's been tests with pozzolan?
Yeah, that would be the supplemental cementitious materials, fly ash, slag, crushed glass, things of those nature.
Yes, there's the fly ash has a pozzolanic reaction with the PLCs and OPCs, obviously, but the results have been favorable, right? Slag would be kind of the one that kind of is very successful. But as far as fly ash, it does as well. It provides a pozzolanic reaction, which is very beneficial to reduce the calcium hydroxide in the cement, because that's a weak link. So it provides that reaction in order to consume those carbon hydroxide in the reaction. And yes, it is a lot of testing was done with the fly ash as well. Yes.
And is the reduction of PLC cement's carbon footprint just happening on the manufacturing process or in the mixing pouring process?
Well, you can do it two ways. So just for PLCs specifically, type 1L cement, we're reducing the carbon footprint in the manufacturing process by the reduction of the amount of clinker used in the cement by way of increasing the amount of limestone. So that's what's giving you that roughly 10% CO2 reduction in the manufacturing process of the cement. Now, that being said, the poured in place concrete can be further reduced by using supplemental cementitious materials and optimizing mix designs. For example, some of the projects we viewed had upwards of 50% slag and 50% type 1L cement. So you can further reduce the carbon footprint of the finished product by using SCMs in the mix design. Byron, what are your thoughts? Anything additional?
No, I mean it's a you said it perfect, Justin, and actually the if I go back to the governmental entities, the Department of Transportation, they encourage the use of SCMs in all of their products: slag, fly ash, metakaolin, silica fume, and so on. So yeah, I mean, as far as the cement manufacturer, I mean, that's just the first step, right? By producing PLC and reducing the carbon emissions. There's going to be some more kind of a testing here in the next few months and years where we can further reduce our carbon emissions. But for the time being, I think PLC is just the quickest way and the less the most efficient way to doing it right now very quickly.
No, I agree. And in looking at the PCA and the GCCA's roadmap to carbon neutrality, they look at a holistic approach in the supply chain. So the cement manufacturers are doing their thing, the project designers are doing their thing, the transportation is looked at, the overall mix design. So it's a holistic approach to really reduce the carbon footprint. But specifying and using Portland limestone cements is one piece of that the cement manufacturers can control.
And last one we got in here for right now. What's the greatest or max strength that you can achieve with it?
I think that's going to vary from manufacturer to manufacturer. I would recommend reaching out to the local manufacturers if they're here in Florida. One of the four mentioned, Argos, Ashgrove, Titan, or Cemex. And it's also going to rely on the overall mix design as well, right? So how much SCMs you're using, what quality are they, your sand, your aggregates. I think one of the project examples with their specific mix design achieved PSIs of, I want to say it was something like anywhere from 10 to 20,000 PSI. So I would assume you could do everything equivalent to ordinary Portland cements. Byron, you have any insight on that?
Yeah, no, and I agree. I mean, that question is it's pretty wide. It's because look at one of the projects, the Virage, that was used as a post-tension slabs or decks, and they were able to reach 8,000, 10,000 psi, in 28 days. So overall, no, I mean, you can probably do the same thing as OPC. There's really not a limit. You have to optimize your mixes, obviously, and you have to know what you're doing. You have to know what you're looking for. But in this moment, we're working on an ultra high performance concrete that will give you a strength of 15, to 20,000 psi in 28 days. So we're kind of testing and incorporating the PLCs into the mix, and first the initial test results have shown to be very positive. So yeah, to answer your question, if you optimize your mixes, I mean, you'll get what you're looking for.
Yeah, I think the key takeaway here is that ordinary Portland cement type 1-2 and Portland limestone cement type 1L are really plug and play products with very comparable results. But that being said, you still need to optimize your mix designs and you still need to do the testing to validate it. All right, well, that was the last one, Carl. Any more?
If everybody has further questions, we'll leave it on for a few more minutes, and we'll answer this separately offline, but appreciate everybody coming today.
Yeah, thank you all for your time and your participation. And as always, if you have any questions, feel free to reach out to Byron and I individually or the Florida Concrete and Products Association.
Thank you, everybody.